Okay.
They're on the same channel, I guess.
Oh.
All right, there we go. Hi, everyone. Thank you for coming. As you know, it's the San Francisco MySQL meetup group. If that's not what you're here for, well, stick around anyway. It'll be an interesting night. Tonight we have Vadim from Percona. He's going to talk to us about their new clustering solution. Clustering is awesome. It's so awesome we're going to have 2 talks back-to-back about it. So on April 25th, we'll have one about MySQL cluster. But tonight should be pretty interesting. It's a new product, and I know I've been really looking forward to it. A couple of quick announcements. The meetup tonight is sponsored by Continuant, by IGN, and by Percona. Normally O'Reilly is also a sponsor. However, I have yet to order new books for us this year. So if you have any suggestions for what books you want us to raffle off from O'Reilly, let us know. Also on April 12th, there's a large meetup down at the Microsoft building about Node.js. So I know that doesn't always go well with DBAs, but sometimes it does. If you're interested in that, it'll be a good talk to go to as well. April 12th, sfphp.org will show you that one. Robert from Continuant had something he wanted to say. Where did he go? Whoa, right in front of me. All right.
Thanks, Mike. Hi, my name's Robert. I'm the CEO of Continuant. We have a product called Tungsten, which is database clustering and replication. And I just wanted to announce that we're looking for more people. Like Percona, this is a great business to be in. Just a little bit about what we do. Our biggest customer is, there we go. Well, don't go there. Come to Continuant. And I'll tell you why. Our biggest customer runs about 500 million transactions a day across 16 clusters. All runs on software that we produced. In fact, software that I personally wrote in some cases. The largest system we're building this year is designed to support about 100 million users. It has a design ceiling of 1 billion users. We're doing some really interesting data processing. So if you have a background as a DBA or DevOps, that kind of thing, definitely come talk to us because we have positions open and we will have more, I hope, over the course of the year. So we'd like to meet you if you think you can help. Thanks.
All right. Switch it off and we can kick over to Vadim. Anybody else have any quick announcements? Looking to be hired, looking to hire?
Hi, my name is Joel. I work for a company called Jawbone. We make Bluetooth accessories. It's actual real hardware. It's one of the first times I've worked for a company that makes physical things. But we also make Bluetooth speakers, and we make a health product, a little bracelet you wear and it tracks that, and we store all that in our back-end systems. We're looking for someone sort of developer / MySQL expert, not strictly a MySQL admin and not strictly a Python developer. We're mostly a Python async shop. I run the site ops team, and I have a sheet over there that has the job description and some information. If you have some time to talk to me afterwards, you can talk to me, or you can grab the sheet of paper, and it's got the hiring manager's email on it. So thanks. Anybody else?
Sorry, one more. Hi, guys. My name's Amanda, and I'm actually a technical recruiter from Yelp. And just like these fine folk, we're also hiring for DBAs. We have systems infrastructure developer open, DevOps, and also system admin. So if you guys are interested, come find me afterwards. Thanks. Anybody else? One more, sorry.
All right. So I'm Simon with Taos, and we are also hiring Unix admins, DevOps, DBAs of all stripes. In particular, right now, we're actually trying very hard to find some SQL Server and Oracle DBAs for anyone who'd like to play on the dark side of the Force.
Anyone else? All right. So everybody can also remember to turn off their cell phones, computer audio, all that kind of fun stuff. That will kick it over to Vadim.
Yes. Hello. Okay. My announcement is, of course, Percona Live, MySQL conference, April 10 to 12. I hope to see you there. And of course, we are hiring. Everybody is hiring, so it's not news. And let's go to my talk. Oops. One second. Okay, it's better. I'm Vadim Tkachenko. I'm with Percona and also occasional author on MySQL Performance blog. And today, my topic is Percona XtraDB Cluster powered by Galera replication. And the 100% question what I'm getting every talk I give is, will this talk available online? So yes, it is already available online. If you have a laptop, you already can open it to check speaker notes, to browse back and forth. I just give a couple seconds if you're looking for URL to open this talk. So today I want to focus on high availability questions, and I personally define the current MySQL stage as stage of high availability solution. And there are already a lot of materials on how to tune, how to perform with single MySQL server. HA for MySQL is still on raising stage. And you may see increasing interest to many third-party software and scripts like Continuant, MHA, MMM, Flipper, Percona Replication Manager, and like that. And also, I will talk about replication solutions and clustering solutions. So first, let me just define what is really high availability. And availability refers to ability for user to communicate to system, submit the job, get a result of work, run some queries. And if user cannot access the system, it is said the system is unavailable. And word high refers to some pre-arranged, predefined level of performance for a specified unit of time. And the usual approach to provide availability is to have redundant systems. This is especially useful if you have system services like web server or application server. And basically what we do, we just duplicate our resources. And failover is very simple. When one system is down, we redirect a request to second system. And it actually applies to more than two systems. Having multiple servers helps you to manage probability of failure. If single server has probability P, then two servers has P divided by 2, and X servers P divided by X. And graphically, we have some inversely proportional function. The more servers you have, the less probability of failure. And was that too easy for availability? Yes, but not if we deal with databases. And database is more complicated. There's two parts. There's system, server, and data. And beside system redundancy, we need to provide some data redundancy. And to provide availability for database, we need to provide availability for two components, servers and data. And this is where replication can come into play. Replication is a process to share events between resources. When one of system updates data, it informs other systems. So let's talk a little bit of MySQL replication, as of course it's most known in MySQL world. And how many years I work with MySQL, I always have impression that MySQL replication is a system with some live support subsystem. When you do something wrong, it just tends to break very easily. So, well, maybe I exaggerate a little, but I just to draw your attention. And yeah, to be fair, there are a lot of MySQL replication setups that serve HA, and they're doing a great job. And what's wrong with MySQL replication, I will explain just in a couple minutes. And for me, it's just a simple A in asynchronous. Because MySQL replication by nature is asynchronous. What does it mean? There's no confirmation of event or not guarantee that event is applied on replicating system. And by its nature, it kind of assumes there is delay between master and slave. And the delay can be microsecond or maybe hours if you're not lucky, or if system is down, it may be just days or something. So in a simple term, asynchronous does not guarantee that your data is the same in a given point of time. Synchronous communication is different. It assumes confirmation process, and the first system is waiting on confirmation. So you may ask, is not this how DRBD works? Well, yes. However, with DRBD we have a different problem. While with DRBD data is available, the system is not. And as you remember, I refer to my slide, we need to provide availability for two components, server and data. For DRBD, usually you have second system down, and in case of failure or first system, it might take some time. It may be a very short period of time, but maybe not. In any case, it is not zero time to do failover procedures. And there we come to clustering solution. And exactly to Percona XtraDB Cluster. As usually, it is free and open source. You're free to install, use, uninstall, copy, distribute, provide commercial support, or write books, whatever you want. In a Percona XtraDB cluster, the nodes are connected through group communication and inter-exchange events in a synchronous way. Well, actually, it's not really synchronous. It has name virtually synchronous. I will not go into details. It's a lot of just too complicated topic. If you want, you can go to that link and get familiar yourself. And I still tried to explain how it works in simple terms. This is simplest way I could come up with. The important points on this schema is that all network communication happens on commit stage. On commit stage, a node performs communication and certifies transaction. Sorry. And this is stage where response time on commit also comes into play. So commit might actually take some time because it is network communication between nodes. And if your nodes actually on different continents, you may expect some visible delay. Like in my test between Amazon instances on West Coast and Amazon instances on Europe, it was like 200 milliseconds response time between nodes. So let me list all benefits what XtraDB cluster provides. So first, as I said, synchronous replication. Second is multi-master replication. In a regular MySQL replication, you can actually write to several servers, but you're looking for big trouble. And this comes from the fact I already mentioned. Being asynchronous, the second server may be behind, and if you do updates to slave, you might actually update stale data, and your data become inconsistent. With the XtraDB cluster, it is different. You can actually perform arrays, perform updates to any node in your cluster. We also provide parallel replication, which is known as parallel applying events on slave. So with MySQL, again, very known limitation. The MySQL is single-threaded, and this is additional factor why slave can get behind of master. If you have 32 cores, the master can perform much more operation per second than slave you can handle. With the XtraDB cluster, you can configure how many parallel threads you can have on your slave, and your events will be applied in parallel. Fourth benefit is data consistency. And in XtraDB cluster, we guarantee that the data is equal on all nodes. Transaction is either committed on all nodes available in cluster or not committed at all. And we have automatic node provisioning. What does it mean? When a new node, if you have a working cluster and the new node joins cluster, it automatically copies data from one of working nodes. The finishing with the benefits, I want to give some attention to CAP theorem. You probably heard about it. It's especially popular with different NoSQL distributed system. And I will try to explain difference between MySQL replication and XtraDB cluster using CAP theorem. Basically, if we simplify that theorem to next statement, then in distributed system, you can have only two of following choices: data consistency, node availability, or partition tolerance. And I understand it's might still be a little fuzzy and unclear how you can apply that to your case. So let me show you following example. Imagine system is 3 nodes, and we have network failure to one of nodes. With MySQL replication, you get access to all nodes. Even in one node disconnected from cluster, you can connect to that node locally to retrieve data, to update data. But it also means that that node will contain data which is not the same as other 2 nodes. With the XtraDB cluster, we guarantee data consistency, but downside, we cannot allow access to node that disconnected from cluster. And as a consequence, the minimal recommendation we have is to have 3 nodes. Why? Let's see what we have with 2-node case. In a 2-node configuration, in case of link failure, we have a special case with name split brain. And we cannot pretty much decide which node can accept queries and which node. And by default, what happens with XtraDB cluster, both nodes will not accept your queries. And however, we still have special option to enable it, but you basically take responsibility on yourself. And you need to make sure you have only one master, that is server, which accepts update queries. So once again, back to CAP theorem. This choice shows principal difference between MySQL replication and XtraDB cluster. In MySQL replication, you have access to all system. In XtraDB cluster, you have data consistency. And this actually applies to all external software and scripts which based on MySQL replication. MMM, MHA, Flipper, Percona Application Manager. With all that system, you not guarantee data consistency between nodes. And at this stage, I want to give details on Percona XtraDB cluster. Percona XtraDB cluster, it is all the good Percona server, plus special replication patches, plus Galera library. The patches and the Galera library are developed by Finnish company Codership. And what does that mean? The fact that XtraDB cluster based on the Percona server, which is compatible with MySQL, means that XtraDB cluster is fully compatible with MySQL setups. You use the same InnoDB storage engine, and your database behave the same way. The query execution plan is the same. You can use the same regular performance optimization techniques. There's also minimal efforts to migrate from existing working system to system running XtraDB cluster. It is not much harder than upgrade MySQL to Percona server. If you did that, you know, it's just a matter of replacing a binary, and you have everything running on file. And for cluster, you will need to make a couple changes to configuration file. And what also important, if you don't like that solution by some reason, if it does not work for you, it's too buggy, you got annoying, there's no lock-in. You can always return back to your previous Percona server on MySQL setup. There's no, it's very easy procedures like just replace binary. Yes, question? Sorry? But XtraDB storage engine is totally compatible with InnoDB. You can get back from XtraDB to InnoDB very easy. So is this sounds so good? Is this a perfect solution? Yeah, I want very much to answer yes, but you probably won't believe me. Sure, there's some limitation, and let's talk about limitation. It is, of course, new products. And we have some limitation. Some of them are design limitation. Some just need some work to do, and they will be just resolved sometime later. First limitation is that only InnoDB tables are supported. Changes to MyISAM tables are not replicated. So if you want to try this solution, you make sure that you have only InnoDB tables. Next limitation is incompatibility for application. We introduce optimistic lock-in for transaction running on a different server. To get more information about optimistic, you can get by that link. Let me explain what it possibly can do for you. This is traditional locking. In the traditional InnoDB locking, when we run transaction on the same server, and two transactions compete on the same record, second transaction actually will wait until first transaction decide does it commit or roll back, and only after that transaction 2 will proceed. In the XtraDB cluster running transaction on different servers, we can get actually error on commit statement. And once again, it applies if you're running transaction in multi-master mode, if you run transaction on different nodes. In this case, both transaction running with assumption there is no log, no row conflict, and basically they resolve all conflicts only on a commit stage. Again, all communication between nodes happens on a commit stage, and if on that stage the nodes decide they had conflict in transaction, one of transaction has to return error. And I understand it can be quite significant in compatibility with current application, because a lot of current application I know, or database frameworks, they actually do not handle commit statement. They just execute commit and ignore any consequences. Like if there was error, application probably will not see it. But I want to say this is incompatibility, but it's probably only one significant incompatibility you may see running Percona XtraDB cluster. Next limitation is that write performance is actually limited by your weakest node in the cluster. And this is, again, price we pay for data consistency. If one of nodes becomes suddenly slow by different reasons, like disk failure in the disk array, write queries equally slow on whole cluster. Let me show why. Because when we run update on one of servers, the write event is communicated to all nodes, and the user actually gets confirmation only after server gets confirmation from every node. If one of nodes is slow, the whole cluster is slow. And on the same write intensivity node, if you have very write intensive application like hundreds, 1,000 updates, deletes per second, you may face some limit of how much data you can have per node. And this limit is rather logical than physical. And let me explain why. And also I will show the join process, what happens in XtraDB cluster when one new node trying to join existing cluster. It has to copy full data from one of existing nodes in cluster. And what happens in this case, the cluster allocates one node which gets status donor, and the joiner copies whole data set from donor. And you understand, if you have, say, 200 gig of data and a slow network, actually it might take some time. In the meantime, also donor gets temporarily out of cluster. It may be short or long period of time. It actually depends on what copying mechanism you choose. I will show different copying mechanism in the following slides. So now when data copying finished, we have two nodes disconnected from cluster. And what they need to do, they need to apply all events what happened in cluster until they were disconnected. And you have a very big database, and the copying time was long. There may be quite a lot of events happened in cluster during that time. And it might take time for them to join. And while they apply that events, new events still happening in cluster. It's kind of like this catching process. Actually, with very write-intensive application and with big data set, it may happen that two outsiders will never catch up to get the same data set as whole cluster. So what to do in this case? I'm saying this should be not only software solution, but it should be a hardware plus software solution. And this actually applies not only to XtraDB cluster. Let me show you some analogy. It's actually very similar with InnoDB write performance. If you have very intensive write application based on InnoDB, your single disk is not able to handle that. You need to do hardware upgrade to have disk array. And if write performance, you also need durability. You cannot have just a disk array. You need to upgrade your disk array to have cache backed by battery. And the same applies to cluster. If you want a good write performance with the cluster, you might consider to upgrade your network to 10 gigabits to InfiniBand, and you might consider to upgrade your storage to SSD or PCIe flash cards. And let's back to join process. As I promised, let me review mechanism what XtraDB cluster can use to copy data. This process has special name, state transfer. And in the XtraDB cluster, there are two state transfer. This is full copy data set. This is snapshot state transfer. It happens when totally new node joins cluster, or if the node was in the cluster but get disconnected for a long time. And another mechanism is incremental state transfer. This happens when node was disconnected for a short period of time. In the snapshot state transfer, we have following choices. MySQL dump is obviously useful if you have some small database, if you just want to play around. We have rsync process where data is copied using rsync. Usually this is fast way to copy data, but the drawback is that the donor disconnected for whole copying time. And we have extra backup SST method. With extra backup, your donor disconnected for a very short period of time, but copying data is actually slower because with extra backup you have additional data consistency checks, and with extra backup you have InnoDB recovery process. And incremental state transfer is used when node was in the cluster but disconnected for a short period of time for some maintenance, for example, server restart, or you just need to some configuration changes and need to restart node. And it actually may be used when node crashes and then starts. It will be used in future. Right now, in this case, node still will need to perform full data copy if it crashed. Okay, if you're still with me, we can go to scalability topics. And scalability, for me, is quite similar to availability. And that's why we can use XtraDB Cluster for needs to scale our load. Because scalability is similar to availability in the sense how it can be handled. It can be handled by redundancy. In this case, the only difference is that first system is not able to handle user request, not because it is down, but because first system is overloaded. But for end user experience, it is basically the same. The system is not available to handle user request. Having a redundant system, we can redirect user to another system. And the XtraDB cluster, with XtraDB cluster, reads scalability is easy. Reads queries does not require additional overhead or group communication. And write scalability is more complicated, as each write has to be replicated on each system. That means each particular server has to handle writes from all other servers. And if you can make some rule of thumb, it's very approximate, but just to get you some idea. So if you have n servers and your workload 100% reads, you can scale as much as n factor. And for 100% writes, you probably will not see a big scalability factor. It may be 1 or just some constant. And for a mixed workload, you can probably expect n divided by 2 factor. Or if you do some simple calculation for 10 servers, if you have 100% reads and one server handles 100 queries per second, 10 server will be able to handle 1,000 queries per second. And for mixed workload, you can expect 500 queries per second scalability. Yes?
Wouldn't the latency of the synchronous stuff make the 100% writes scale slower? Have additional costs?
Latency, actually we'll talk about it later, but let me talk now. The latency might increase, But you have two factors, this virtual synchronicity and the certification process, which actually makes that not so bad. And this only if you speak about latency. If you speak about throughput, throughput actually not affected that much because we can do all events in parallel. So throughput is not affected much as latency. So I talk about XtraDB cluster with people, and it sounds a good solution, and I'm getting quite a lot of questions. So I just decided to share the question I'm asked. So one of the questions, so it looks so easy, why didn't you implement it like 5 years earlier? And well, actually it's not that easy. This is computer science and academic research and group communication and distributed transactions. And there I should give credits to Codership company who they did all hard work. How fast is it? This is back to your question. So yes, with all this group communication, synchronous processes, is it fast? And I would say it is reasonably fast. And again, we have that virtual synchronicity, we have certification process, and response time might actually take hit. If you see problem with response time, again, you might look into better network configuration and better storage system. And the throughput is actually less affected. You might expect about the same throughput, and you might expect reasonable numbers from throughput. Next question is, can you replicate XtraDB cluster to MySQL replication? Yes, you can. And this is one of configuration actually which can be used for intercontinental or replication between west and east coast. So in data center you have XtraDB cluster and you ship events using asynchronous process to deal with latency problem. Would I personally install it on production system? Yes, and actually I'm going to install initially on mysqlperformance.com, MySQL performance blog to run XtraDB cluster. How it is compared to MySQL cluster? Yeah, I do not like this question. I usually answer it is different. I mean, it's a really different system with different goals, how you can compare it. But usually people do not like that answer. So I came up with this marketing-like checkbox, green, red stuff. And for me, with XtraDB cluster, you have a very easy way to migrate, very easy way to use. It is working in the cloud, in EC2 environment. With MySQL cluster, you need to make changes to your application. But also, you can use MySQL cluster to provide write scaling, which, as you see, XtraDB cluster may be not best solution for that. And also, MySQL cluster is known as carrier grade, providing 5 nines availability. This is just, I put some resources which may be useful for you to take a look. And again, replication patches and Galera library developed by Codership company. And well, that's it from me. I'm ready for your questions. Yes? Yeah, that's a buffer. Buffer is the same like with a regular MySQL or Percona server. It's InnoDB buffer pool.
So it can, in some ways, sort of add some partitioning of your if you hash out your writes and reads to different members of those, you have the.
Well, still, if you hash writes again, because writes actually needs to. Yeah, it needs to happen on everywhere. It will not help you much. Yeah, your question?
What's kind of the perfect scenario for when you use it?
Perfect scenario?
Yeah, so what's like this,
Again, if you need data consistency, if you do not like when your slave getting behind master, I know a lot of people do not like that. Like when a slave 30 minutes, 1 hour behind, and they cannot solve it. And with XtraDB Cluster, you can use parallel slave mechanism. And also, many people ask, can we actually write to multi-master? Even if we have this multi-master MySQL setup, it is very annoying that you cannot write to both master. Actually, you can, but usually it comes with problem with data consistency, with different errors. And with XtraDB Cluster, if you want to write to different master, you can. But you need to remember about that optimistic locking stuff. Ryan, go. No, not at this moment. Yeah, your question?
So it seems like client load balancing is a pretty important thing on top of this.
Sorry?
So client-side load balancing?
Load balancing, yes. We have a recommendation for HA proxy. So you can use HA proxy, and you have some scripts in XtraDB Cluster which you can give some idea how to install HA proxy and how to use it. Yeah, your question?
You were talking about range and whatnot. For the actual file system, what you recommend for XtraDB, NFS, InnoDB?
It should be local storage and as with
So you don't recommend going against SAN? Here at IGN, we used a NetApp filer. So would this not work well with the NetApp filer then?
Actually, it might work if we can adjust data copying mechanism. It is just it is not there yet. So far we focusing on local storage. Yes, go ahead.
Big syntax easier than like change master? Is it just like add member, or you didn't show any actual like demos or big?
Okay, how to configure it? Well, it is very simple. It is just one command line. You saying join cluster with IP address, and it will go and join.
Is there different users without authentication? Is there encryption important for the communication between members?
Again, it depends on what copying mechanism you choose. If you do MySQL dump,
But after they're all synced?
after all, no, there's no special user. It all happens inside system. You cannot control that.
SSL?
If you want to protect your data, yeah, you use SSL. It supports SSL connections. Yeah, your question.
For clarification, I want to know, I have 4 different servers which are talking to each other. We have a group communication, everything is set up. And you said if one of the nodes cannot commit it, none of the transactions will be committed. What's going to happen if one of my nodes get disconnected or shut down the server? What's going to happen for
There is timeouts. If during some which is configurable, you can configure how long a cluster will wait for a disconnected node. If it exceeds timeout, that node will be thrown out of cluster.
And when it comes back?
When it comes back, it can copy data back. If it was disconnected for a short period of time, it can copy data incrementally. If it was a long time, it need to do full copy of data.
So in that
Yeah.
case, what happens to the data that's not propagated to the other servers?
Sorry, I don't follow you. What?
So if one of the nodes goes offline,
Yes.
and presume that there was some transactions that were with that server, on that server, what happens?
So again, you, as I showed in CP theorem, if one node gets out of cluster, you cannot run transaction on that node unless you go and especially reconfigure that node to to accept transaction. So by default, it will not accept your transaction if it gets out of cluster. Yes. Yes, sorry.
So when I go to write to the cluster, I'm writing to one IP address that writes to all of them. I'm not writing to each individual box. In other words, I'm not connecting to each individual box. I'm connecting to like a bit.
No, you can connect to any of nodes. You pick one which you like, and you can run queries to that node. Internally, then they communicate internally.
But then we have the problem that like you just talked about where I'm writing to, for my website, I'm writing to one node, that node goes offline. I'm no longer writing to anything. Right?
If you connected to node that went offline, you will not be able to write to it. That's why we have HA proxy. With HA proxy can monitor which nodes are active, which passive, and if you use, yes.
Then we
No.
lose data consistency, right, across nodes.
The write won't complete. So if
Yeah.
it's for all the other members, but that write is been written to all of them.
How does it handle auto increment?
After incremental.
Auto increment?
Auto increment and increment where you, like when you do master, can you tell where the write was originally sent to?
Right. So if I'm writing to a table that has a column auto increment, and I'm writing to that same table somewhere over here, how does it resolve what?
For after incremental, by default, cluster increase that InnoDB auto increment step. So each of a node in cluster will have different auto increment offset.
So
Ye-
one will be even, one will be odd.
Yeah. If you have two that even odd, if you have three, it increments by 3. Mike?
Can you choose which node is the donor node?
Yes, you can.
So the reason why I ask is scenario of, let's say I need to make an alter table to add an index that takes an hour to run.
Mm-hmm.
Is there the ability to take one of the nodes to kind of an offline state where I can make that change, have it come back in, and kind of one by one?
Actually, it is it probably not fully supported yet, but will fully supported in very soon. What you're saying that alter table will happens kind of in rolling alter schema.
So
Yes?
if I have an alter table that would normally take an hour to run, in this system, would I expect it to take an hour to run? Would I expect it to take longer because of the synchronization?
It depends on what node you connect. For example, you run alter table on one of nodes, so it will run locally on that node, but that node will temporarily disconnected from cluster to not delay from cluster, to not delay whole cluster. But then when update finished, that node will try to connect back to cluster to get all events, what happened, to update that tables will with all events, and then another node will perform the same.
And that happens automatically.
Yeah, that will happen automatically.
In that situation, they'll only need one node out at a time, basically running an alter table. Like 5 servers, I run the alter, run one locally first. Then how do they decide who runs it next, or are the rest of them all just going to run the alter?
It will at this point. Well, it's still this process is still under development, so it might change. It's
What's
Yeah.
your recommendation when I have to mass update? I'm updating a gigabyte worth of data. Do you want the updates to be run on individual servers, or do you recommend it to run on just one, take it offline, and then connect it to the grid?
I'm not sure why. Sorry, why are you asking about taking a node offline? If you do updates, it's update needs to happen on all cluster. You do not need to take node offline.
Well, I'm just thinking if an update takes about, let's say, 30 minutes, how long does it take to propagate across all the servers?
If you have update, the events from that update will copying to other nodes. So probably it will take the same. Well, yeah. To be honest, I'm not sure exactly.
So let's hypothetically take a situation here. I have a server in San Francisco, one in South Africa, and one in maybe Asia somewhere, and I want to do an update to one of the tables there. And I don't want it to be updated here and expect the data to be propagated to South Africa and then be updated somewhere else.
Because you would use the asynchronous replication, standard replication there now, instead of the fully synchronous replication. You would cluster with disparate nodes. Yeah.
Yes.
I'm assuming everything's essentially statement-based, not row-based, or
Sorry.
for the communications for committing all this stuff and verifying it, it's all essentially statement-based replication?
No, it's a row-based replication.
It's row-based.
Row-based replication.
Okay.
Yes.
Do you have a majority vote? Like, what if you have proper split brain where you have 4 nodes, and 2 of them are isolated, and 2 of the other ones are also isolated, and if they both think they are valid clusters, how do you deal with that scenario?
They will decide internally somehow by using communication or not using communication, which.
Well, no, if it's completely isolated and separated, like, how do you separate them? Right. Yes. So do you do a voting pool or some?
Yeah.
At least n members up to be considered valid, or
It is based on a quorum base, so it decides by voting.
So is there any concept of Stone?
Sorry?
Is there any concept of Stone? Stone, where you, if you're split brain, where you could take another node offline?
So.
You never heard the DRBD thing? Purposely killing another node. Shoot the other node in the head.
Okay. Okay. Okay.
Do you have any measurements of the effects of latency? Like, is 10 milliseconds, like SFLA too much? Like, what is the overhead of latency? How many inter-packet calls go for each transaction?
Exactly for latency, I don't have numbers, but I have done some couple benchmark. You can see on MySQL performance blog. Yeah. No. I did the test also for different distances, but my benchmark done in a local data center when you have all nodes in local data center. For case between data center on West Coast and Europe, as I said, you can expect latency like 200 milliseconds delay on a commit.
Cool. Thank you very much.
Okay, thank you.